In terms of band theory, what is the difference between a conductor and an insulator? See, what is the band theory? Band theory says that when many atoms, not just 2, 3, 5, when you have a block of metal, when you have billions and trillions and quadrillions into quadrillions of atoms stacked in together, their energy levels combine. And when their energy levels combine, there are not 2, 3, 5, there are billions into billions into billions of energy levels, and they combine to give you what is called as energy bands. So what is an energy band? A band is a collection of millions into millions into millions of various energy levels of individual atoms. And these energy levels have such small energy gap that you can consider them practically continuous. That means that you can say that if many energy levels are stacked just one after the other, one after the other, one after the other, then you could say that since the difference between them is very small, electrons from one can easily go to the second, third, fourth, fifth. They can move easily within the complete volume. So instead of calling them energy levels, we say there is an energy band. Fine. You find that highest occupied MOs combine to give you a valence band. Okay, and so you have some valence bands. Fine. And then you have lowest unoccupied MOs, orbitals outside which were empty, and they also combine to give you what is called as a conduction band. Okay, and if these bands overlap, if there is no energy gap, electrons can pass very easily from valence band to conduction band. They are delocalized. And if they are delocalized, we say that they conduct electricity. When you have an energy gap of 3 to 7 electron volts, even more, much worse, but usually it is 3 to 7, then you say they are insulators. Which means that, see, the electrons within atoms are in what is called as valence band. If they move to conduction band, they would be able to jump around here and there in the solid lattice or crystal. But since the energy gap is too large, they are not able to jump. That means they are just, moving around here. They can't go anywhere else. So they stay within the atoms. They are not able to delocalize themselves in the crystal lattice. And that is why that solid does not conduct electricity. And we say that that becomes an insulator. Examples of insulator: diamond is a very good example of an insulator, and graphite is a very good example of a good conductor. All metals are good conductors: silver, gold, copper, they belong to this category, and insulators like diamond belong to the second category. Similarly, what is the difference between a conductor and a semiconductor? The first and the foremost and the most important difference is the band gap. Band gap, or the energy gap between the bands. Let me again draw that for you. For a conductor, this is a conduction band. This is conduction band, right? And then there is a valence band, and there is, there is a valence band. 0.6 to around 1.5 electron volt. This is the usual band gap. If this is the band gap, this refers to a semiconductor. So electrons cannot casually walk in, but with little warming up, little motivation, some photons, they can jump up. And you find that the substance actually begins to conduct electricity to a small extent. And this is what is semiconductor all about. Conductors have no band gap, so they can freely conduct. That is no problem at all. That is the major difference between a conductor and a semiconductor.